Severe weather for the Central Plains, but also continued flash flooding for Virginia and North Carolina. Good morning, I'm meteorologist Pew. Today is September 16, 2025. So in terms of severe weather, we have a slight risk, or a 2 out of 5, specifically in Nebraska and a little bit on the border of Colorado and Kansas, and a marginal risk stretching from all the way there to Minnesota. But we still also have a marginal risk in the Virginia and North Carolina coast. And for both these risk areas, we have a 2% chance to see an isolated tornado. In terms of damaging winds greater than 60 miles per hour, we have a 15% chance in Nebraska specifically, but a 5% chance in both marginal risk areas. And for large hail, we have that 15% in the same location and also a 5% chance from the high plains to Minnesota, but not in the East Coast. Okay, so time frames of when this is all going to happen, starting with the Central Plains, places like Wyoming, Nebraska, Kansas, you guys have already been seeing probably some showers this morning and afternoon. And we're going to see intensification of storms around 4 p.m. Central Time. And we're going to see a lot of consistent rain pretty much all day, especially in Nebraska. But overnight, some places may be seeing some showers, especially in Wyoming, South Dakota, and Kansas. Rainfall totals in the next 24 hours, some places could see 1 to 2 inches, but also some places could see 3 inches or greater. And for the North Carolina, Virginia coast, you guys are going to be seeing a lot of rain pretty much all day, all night, and even into tomorrow. But by tomorrow morning, you're going to see less frequency of these showers. So what's happening in the coastline is we kind of have a pseudo tropical storm where we have a low pressure in the Atlantic that's been pushing itself a little bit to the east. And with this low pressure that's kind of clockwise flow, it's been pulling in a lot of moisture from the Atlantic into the coastline. But if we look at 500 millibars or midway to the troposphere, we do have that isolated low pressure system, and that's also kind of clockwise flow that's been navigating that surface low pressure into the coastline. And we also have some decent shear along with that, and that's why we're seeing some of these storms be prolonged, because it's tilting those updrafts. But that's also why we're not seeing an actual tropical storm or hurricane, even though this low pressure at the surface is over warm water. So anyway, speaking of tropics, we do have that tropical disturbance in the Atlantic where there's a 90% chance of something forming in the next 48 hours. But the good news is that its formation path is likely above this latitude, which means it's going to follow Hurricane Aaron's path that we saw earlier in the season. And what we're most likely going to see is we're going to see a tropical storm or hurricane form and go towards the East Coast, but it's going to drift to the east. But obviously we'll keep an eye on it, so I'll keep you posted. And behind it, we do have another tropical disturbance where there's a 20% chance of something forming in the next 7 days. Now on the other side in the Pacific, we still have Tropical Storm Mario, and its path is still going northwest, parallel to the Baja California area. And this may be significant for places like California, Nevada, and Arizona, because there's going to be a lot of mid-level moisture that's going to be advected into this area probably by like Thursday. So we're probably going to see more monsoons. Okay, now back to the plains and looking at 500 millibars, we do have a trough that's in the northern Rockies. And as the day goes by, this trough will become more negative, meaning that the axis of the base of the trough will lean more to the east. And just like I said this week, these negative tilted troughs are going to do 4 things. 1, bring decent shear, which is going to help tilt those updrafts, prolong the storms. 2, bring vorticity or spin or help with the upward motion. 3, it's going to have a matured low at the surface. And then 4, we're going to have cold air aloft, which is going to help those rising air particles rise even faster. And that's why we have